let's continue in our unsupervised learning exercise. Basically, let's inspect the data. The first thing we do, we always try to inspect our data, and we're not going to use data.info here, because most of them are kind of numerical. So, but we can see the player name, the club, age, and value. They're not really important so much, like based on this our problem statement, because the club does not really matter. The people that assigned us a tax um didn't specify any club. Okay, the age matters, but the data set doesn't concern, and there's nobody that's more than 28 years in this, so it's okay. The value, the value is not important, because it can change. A value of a player can change in 10 days. It depends on, it depends, kind of, it fluctuates, I would say. So we can see that this data does not really add anything to the data, to add anything to the segmentation problem we're trying to do, to kind of, what I mean, clustering. Does not like add to it. You will not like you will not group similar items based on these features. So these features will not be needed. So what we'll be needing is stuff like this. These are features that are really important for, they're important to find, so they can find similar their similarities. So we'll be using from here. So first of all, um, when we get this data, we can see that there's a little bit of discrepancies. Let's say this long shot go per game, one shot go per game. You can see it is in a small number, 0.08, and then we have pace 91, 97. You can see even assists per game this session 0.11, shots per game is 3, and we're not having numbers of 91, 85, 65. So this data set is kind of imbalanced, and like we said in the last session about we are doing classification problem based on supervised learning, about majority class and minority class and all of that. And in this time around, we always, anytime, in fact, anytime we're doing unsupervised learning, because we're kind of grouping each features together, so we always need to scale it, kind of put all of them on the same scale. We can't have numbers that are so big and so small. It is kind of going to be skewed towards um now towards the large numbers now, and the small numbers will not have enough weight to influence the decision making. And that is to kind of affect decision making of the data, the main part of the data, I would say. So we need to like scale it so they can be on the same level. So what we do, first of all, we have to scale the data. I will show you a scale data. You can see, we see how um how it will now become very nominal, because now the data is kind of skewed. It has too many numbers, and we will not be able to extract the kind of knowledge we need from this data with that kind of format. So let us create a new text. We're scaling our data. I say I want to use a capital this time around, and I'm using capital. I'm going to capitals. Uh, we're scaling the data. So let's write something on that. So let's say, in order to make sure these values are equally weighted, these values are equally, okay, I'm using my E, weighted, okay, within our model. We will need, sorry, made a mistake again. We will need to rescale the data. Okay. So what we're going to use a method from sklearn. So we just import from sklearn dot preprocessing, import mean max scale. Okay, the columns that we want to scale are SPG, that is this SPG, is this SPG. Just basically all the columns, I would say SPG, pace, DAD, aggressiveness, team player, poacher ability, strength, and some of that. So basically, what we're trying to scale, we're not going to scale these small values because they'll be so messy. It gets so smaller. So we're going to just choose the ones that need scaling. For example, um, SPG, like I said, pace and all of that. Those big numbers are going to like scale. That's what I'm going to scale. So let's write them down. Strengths and all of that. So we're going to copy most of them because it's going to like take a while for me to type it. So let's continue in the next section, please.